Hello there guys, welcome to another C# tutorial. In this tutorial we will continue our speak about for loop, and we won't have anything new about the syntax of it, but rather we will focus on some of the techniques that could be used with for loop to solve some problems. Uh, I don't know if there is a name for that, for the technique we are speaking about today, but basically we will try to do some form of summation. Okay, so I think this will be more obvious if we want to do, or if we get an example and do some calculation. Let's assume that you are supposed to solve the following problem. Okay, you want to find the summation of what? You want to find the total of 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 and so on. This continues up to n values. Okay, so the question is, how do you do that? Well, when you have something like that in programming, usually you have a for loop. Okay, now if you look at here, how do you solve this problem? Well, basically you split the problem into a simpler one. So you can think of it like the following. This could be explained as what? First, you have 1. You have the total of 1 as a first step. In the second step, you find the total of 1 plus 2, right? And then next step, you find the total of 1 plus 2 plus 3. Okay, and in the next step, you find 1 plus 2 plus 3 plus 4. Okay, and so on. So in each step, you could add one single number to the total that you already have. Let's assume you have a box that will have the result. So that one is empty. So first thing to do, you add 1. Next, you add 2. Next, you add 3. Next, you add 4. Okay? So you will end up with the final result. And then, okay. Now, if you think about what we are adding in each step, in this step we are adding 1, right? In this step we are adding 2. In this step we are adding 3 only. In this step we are adding 4 only. As you can see, if you want to have, um, these numbers represent a counter. So let's work based on that. Okay, so we said we need something that will hold our answer or make the computer remember our answer. So we could use this float uh, result equals 0. You could call it result or you could call it sum. Okay, and then we have float n. Let's assume we want n equal to 10. And now we want to find the total. So basically you could say for int I equal, we are starting from 1 and I smaller than or equal to n and increase I by 1. All you have to say is result equal result, previous value of result plus I. Okay, so the first time I will be 1, so it will be, it will calculate this part, and the second time I will be 2, so you'll find the total of 1 plus 2 that will be stored in result. Third time you'll find 1 plus 2 plus 3 and so on, so it will be increasing. Okay, and finally we have system dot console dot write line n equals n, oops, and but we have sum equal result, and finally we have system console read line. Okay, So we spent a little bit of time on this one, although it's very simple, but we wanted to analyze the technique. So let's run this. Uh, okay, and it's working. You can find the total is 55. Now we could actually print the intermediate results in the for loop. So in each step you could write something like this: system console write line I equals, this is the counter, and result equal result. Now you might be asking why we are doing this. Well, this will allow us to see the value of I and result in each single step. So if we have a look now, oops, I did something wrong, right? Yeah, sorry. There you go. Let's run this. Okay, so check this out. When I is 1, the result or our sum is 1. When I is 2, the result is 3. When I is 3, add that into it, you have 6. When I is 4, you have 10. When I is 5, you have 15. When I is 6, you have 21, and so on. Okay? It's as simple as that. So you can see how the previous calculated value is used to find the next one. So in the first step, the previous calculated value is 0, so you add 1 to it. And in the when I is 2, you are using the result of when I is 1. When I is 3, you are using the previous result of I, right? And so on. Okay, so this is the basic idea. You use the previous result in order to find the next result. Okay, okay, so we finished this very simple example, which is the summation. Now let us consider okay, I'll keep this for a second there if you want to pause the video in order to copy the available text. Now let us think of another example. Instead of using a simple summation, let's say you want to find the multiplication of number. Okay, so I'm going to change this now. Now instead of this, what do you have? You have something like this. You have I wait a second, let's say maybe I should say paint over here. Okay, how am I gonna do that? Let's say you have 1 plus, sorry for my very bad square. Oh, maybe I shouldn't have used paint. Yeah, because this is very horrible. Anyway, let's say that you have a similar equation. You want to find 1 plus 4 plus 9 plus 16 and so on. So you continue. Well, if you look at this one, okay, you find that this is 1 square, this is 2 squared, this is 3 squared, this is 4 squared, and so on. So in a very similar technique, okay, uh, here you have result equal result plus, instead of using I, which represents your number, you just update the sum and use I squared. Okay, and the rest will be calculated accordingly. Okay, so now if you run this, you'll find this is, I equal, as you can see, I equal 2, result equal 5, I equal 3, result equal 14, and so on. Okay, so as you can see, I've just updated the calculation here. Now what if the question was kind of different? The question you have, or the problem you need to solve, is this: you need to find the sum of 2 plus 4 plus 8 plus 10 and so on. Now this is very similar to the previous problem, okay, the first one we solved, but we are adding what? We are adding even numbers. Now this could be solved in one of two ways. The first one, let's say I is starting from 2 ending with n, okay? However, here you would say I equals I plus 2, and you can add the value of I. So here your counter is increasing by 2, starting from 2. Add 2 to it, you get into 4. Add 2 to it, you get into 8, and so on. So now let's run this, and you can see it's working. Now it's adding even numbers. So here you have 2, 2 plus 4 equals 6, 6 plus 6 equals 12, and so on. Now this is one way to solve it. Another technique is, well, you start from 0 or maybe 1. You add, you increase the counter by 1. Now you could check if I modulus 2 equals 0. In that case, update the result. Now if we run this code, check this out. When I is 1, the result is 0, because this statement, which is result equal result plus I, does not get executed. This number is even, I is even, so result is not updated. When I is 2, result is updated. I3 is odd, not updated. I is 4, get updated, and so on. So you have seen just that this is another technique. The previous one was a little bit faster, okay, because we didn't add a check here. So if you are doing very large calculations, something like this, removing the if statement and increasing counter by 2 would be a better choice. Okay, so far this is nice and simple. Now what if you are supposed to find a different result? Okay, let's assume now we have another question, which is, well, you are supposed to find the sum of the following, which is 0.5 plus 0.3333, right? Yeah, wait a second, this would start with what? 1 plus 0.5, 0.3 plus 0.25, and so on. Now, if you have a look at this one, this could be explained as follows. This is the result of 1 divided by 1, right? And this is the result of 1 divided by 2. Next one is the result of 1 divided by 3. And this is the result of 1 divided by 4. Okay? So sometimes you have a little bit complicated equations. You might not, you don't know here, for example, at first look, you don't know what is the pattern, what is the relationship between two consecutive number, or how the series is being formed. So you need to to identify what's happening, where the counter is. In this case, the counter is being used for division. Okay, so if we know this, the rest is going to be something very easy. We need to do a division. Did we speak about division before? I'm not sure. Anyway, but it's easy. When you want to divide a number, you use this symbol, right? So we have 1 divided by I. It's as simple as that. Now, if we run this, we will get the wrong answer. Okay, let us run this. And as you can see, this is the wrong answer. You might be wondering why. Well, because here 1 is an integer. And if you remember the very, at the very beginning when we spoke about dividing two integers, the result would result in removing the floating point part. You need to make the compiler understand that this is not an integer division. So you need to add 0.0f over here, and this should solve the issue for you. So now this is a floating point number divided by an integer number. Let's run this out, and you now find the correct answer. Okay, If you would like, we could well, try to make this up to what. Let's make n 100 just out of curiosity. I want to see what's gonna happen. Okay, as you can see, well, it can find the total. Okay, so now we have solved these simple problems. Let us again repeat what is the common practice here. In all these problems, what did we do? We started with something that hold our intermediate result. Okay, in this case we call it result, some call it sum or s or v, whatever the name, doesn't matter. What matters is that you understand what is the meaning or the purpose of this variable. It is to hold intermediate result. Okay, and then you will start a for loop, a counter. In each step, that counter will be used to calculate, one of the intermediate results. Okay, and that will be and your variable will be updated accordingly. Okay, by the end of the loop, you will have the correct answer. Okay, now let us take another example. Okay, um, I'm sure you have heard about factorial. I assume you already know how to calculate factorial. In case you don't know, you have f of x equals it's 1 times 2 times 3 times 4 and so on times n. Okay, so this is basically n factorial. Now we will only use factorial of 10. So the relation between these numbers is what? There is always multiplication. Okay, so all you have to do is you multiply this by what? By I. Okay, so first, now there is one important thing. You must pay attention to the first number here. Now I put 0 over here at the beginning. Well, basically, if 0 is being multiplied by 1, it will result in 0. Multiplied by 2, it will result in 0. So the initialization would cause problems here. Okay, our initial value of result. For that reason, you might want to change this and make it what? 1. Now, if we run this, you find out that we are calculating the factorial correctly. So, it's not only important to define our intermediate variable or intermediate result variable, but it's important to identify what is the initial value. If you are performing a summation, usually you start with 0. If you are performing a multiplication, as in this case, it's important to start with 1. Okay, now another thing I want to repeat. Okay, uh, if you look at this one, you can see when I is 1 you are getting 1 factorial, when I is 2 you are getting 2 factorial, when I is 3 you are getting 3 factorial, 6 is 3 factorial, when I is 4 you are getting 4 factorial, and so on until you end up with 10, which is 10 factorial. Okay, so yeah, this is pretty much the technique you could use. Now, sometimes you might get a little bit different equation. Uh, okay, so let's go back to our first equation, which is the summation, which was it was 1 plus 2 plus 3 plus 4 plus 5 and so on up to n. Okay, so basically this result started from 0 and we were just adding. Well, what if instead of starting from 1, okay, the summation started 192 193, 194. Okay, and you continue up to n. Well, that is also very easy. All you have to do is modify, okay, your starting point or the start of your counter. Okay, so let's assume that it's between 192 and 200. Okay, so if you want to run this now, check this out. We just modified the initial value, so you can see here, you know, you can see there's always a way to calculate it. It's just the beginning value of our counter is being changed. Now, this is one method to do it. Sometimes it's not like that. You have something like this and then followed by 1 plus 2 plus 3 plus 4 plus 5 and so on plus 10. Now if you look at this one, in this case, this part we solve it as what? We solve it as a simple summation, just a for loop and sum these values, but this part is not right. However, it's being added, so you could simply perform the summation first and then you would say result equal result plus 9283, for example, or you could just change the initialization over here. Okay, so as you can see, it's you know, I'm just showing you this here. Okay, it's pretty much in all these examples we were trying to figure out what part is being affected by the counter. We used a variable to calculate uh, the total or intermediate results in order to reach our final result, and if there is any value that doesn't belong to our pattern, uh, programming pattern I mean, okay, we either put it in the initialization or add it to the final result later on. Okay, now let us take one final example. Let's say you have this thing over here. Okay, you have n factorial divided by well, summation of n, which means the sum of 1 2 3 4 up to n. Okay, so obviously here we need to find n factorial and we need to find the summation. Now this for loop calculates the summation. Okay, I will change the name of the variable. I will go to refactor and I will call rename. I will call this summation. Okay, and apply. That's it. I don't. Okay, this is just for speed, no problem. So here we found the summation. This part is used to find the summation. Now, in a similar fashion, okay, I will hide this part so we don't get any extra lines of code or text that will confuse us. We will define another variable, float factorial equal 1. So this part, wait a second, okay, this part already finds us the summation. Now, in a similar technique, we will find the factorial. For int I equal 1, I smaller than or equal to n, and I plus plus. Factorial equal factorial. Multiply this by I. Okay, so now the final result is what? Factorial divided by summation. Okay, so now you see that in this case we needed two calculated values, right? So we created code to find this part, and we created another code or another for loop to find this part, and we divided one by the other, and we can now run this. You can see the result over here. Another way to do that, since they both share the same counter, you could just combine them together. It's not always the case, but in this case it works. Why? Because summation is adding 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, and factorial is multiplying by 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Exactly the same counter value is being used for both calculation, and because of that you can use the same for loop to do both of them. Okay, so just pay attention to these simple details. They could help you a lot, speed up your code. And yeah, um, I guess that's it for today. So to recap what we have just said today, basically in some calculations you might need to use a counter. Okay, uh, what you need in these calculations that in these calculations is a variable that will carry your or help the computer remember the intermediate results. Okay, in this case we have summation and factorial, right? Next you will need the counter, okay, which is the for loop variable. In this case it's I, and at each step you are updating your summation or factorial or intermediate result variable and getting closer to the final result. Okay, you keep on doing that until you exit the loop where you should have the final result. If if you are doing multiplications, you need to pay attention to the initialization. Okay, so you don't have to get a zero, that is which is a wrong answer in this case. If you are doing a summation, usually you start with a zero. Okay, it's not always the same. So some equations have some numbers that doesn't belong to the pattern, so these numbers could be added later on. Okay, and I suppose that's it. That's all for today. Thanks for watching and have a nice day. Bye bye.